Welcome. My name is Tomasz Śpiewla. I'm working in Center of New Technologies in Warsaw, Poland, and I would like to describe you my project titled Microscalar Thermophoresis-based assay for the evaluation of interaction of IFIT1 with RNA cap analogs and capped RNA. Eukaryotes have developed a number of complex immune systems to protect themselves from viral infections. One of them is the interferon-induced protein with tetricopeptide repeats, IFIT, which are responsible for binding to viral RNA and thus blocking its transcription. The IFIT1 protein has been shown to bind most strongly to RNA molecules with cap0, which is characteristic for prokaryotes. However, the effect of other modification on the 5' end of the RNA on the affinity of the IFIT protein has not been reported. The main idea of the project is to obtain IFIT1 protein and then to determine dissociation constant on the basis of microscale thermophoresis measurements with ligands for this protein being pure cap analogs or capped RNA molecules. The first step was to express the IFIT1 protein in a prokaryotic E. coli-based expression system. Purification of the protein with the histidine tag was initiated using affinity chromatography on nickel beads. The second step was to use heparin column to remove bound nucleic acid molecules. And finally, the protein was purified by gel filtration to obtain pure preparations without majority of impurities. Microscale thermophoresis was used to measure dissociation constants. This method is based on the phenomenon of thermophoresis, which involves directed migration of particles in temperature gradient. The measurement started with optimization of conditions, and on the basis of stability checked with the use of Tycho device, the best conditions for conducting the measurements were selected. First, dissociation constants were measured for the reference cap0 and cap1, obtaining for cap0 Kd at the level of 100 nanomole and for cap1 at the level of 350 micromole. Next, the affinity of the IFIT1 protein for other analogs of the cap0 was tested as much as lower affinity were obtained than for N7GPP-APG. Two non-canonical cap found in human cells were also measured. For the TMG cap, a Kd was obtained at 300 nanomole, and for the NAD cap at the 430 millimole. So the difference is huge, although for the NAD cap, we did not reach lower plateau for the curve. Summarizing this set of ligands, we conclude that the strongest affinity of the IFIT1 protein for the cap0 and 7-GPP-APG was confirmed. Interestingly, these changes at the second position on the cap significantly weakened the affinity, as did methylation at this position. We proceeded to examine the ligand of the capped RNAs with the IFIT1 protein. Affinity was measured for capped RNA with cap0 of 35 bases length, obtaining a Kd of 9 nanomole, for RNA 35 with cap1 obtaining a Kd of 26 nanomole, and uncapped RNA 35 also was measured, obtaining a Kd of 5 nanomole. Additionally, measurements were also performed for longer RNA molecules of 70 bases in length. For RNA 70 with cap0, the Kd was 18 nanomoles, and RNA 70 with cap1, Kd of 15 nanomoles was obtained. Non-canonical cap with RNA 70 were also measured. For TMG RNA 70, a Kd of 16 nanomole, and for NAD RNA 70, a Kd of 60 nanomole was obtained. And to summarize, the second set of ligands, the general trend of affinity strength were retained, but the range of differences compared to cap alone ligands decreased significantly. This may indicate a strong effect of the RNA chain on the affinity of the IFIT1 protein. We intended to study more cap analogs and RNA with caps to get a broader picture of the effect of this modification on the interaction strength. Thank you all for your attention.